So guys, okay, the first of its kind, the chemistry post-UTME section from mostly academic. Like I said, it's going to be a long section, but this first particular 35 question is just to keep you guys to get started and let's see what you can do. Like I said, it's going to be chapter-wise stuff, and we're going to be talking extensively. And I'm going to be using the interactive board also as well to make you guys see how to feel chemistry. And if you're a newcomer to this channel, kindly subscribe to the channel and you can drop a comment to let us know how to serve you better. So we start with this set of questions. Like I said, questions are prepared by my admin. I only want to do this first one. Then topically, chapter-wise, I'm going to face the questions and giving you line by line explanation of chemistry. Chemistry is mostly known by observation. So you have to observe. So when you observe, you can take the rest on your own. The first question given to me here by admin is a question on the solubility in moles per VM cube of 20.2 gram of KNO3, which is called potassium triisonitrate 5, KNO3. Now, that's the first thing. This is a salt, and this is a normal salt. So if you get the molar mass, which you are going to use, it's dissolved in 100 gram of water. I do tell my students, when you are doing solubility and you come across something that dissolves in an amount of water, you take it to be the volume, even if it is given in gram, for direct formula-based question. So you keep this in mind. So basically, solubility in moles per dm cube in junior class is given as solubility in moles. There are different ways you can solve questions like this, but I always believe using formula base is always good. Mass over the molar mass multiplied by 1,000 of the solvent divided by the volume of solvent. So I hope this is explicit enough. So KNO3 molar mass is very, very important. So doing that, as you can see, we can say this is 39. So far this is 39. We say we have 39 plus oxygen is nitrogen is 14. You can see, and this is having 300, which you are going to use to multiply 16 of oxygen. 16 3s are 48. This is 101 gram per mole. So substituting that, you are going to have mass of the salt. The mass given here is 20.2 divided by the molar mass of the salt. You just see that 101 times 1,000 over, because this is dissolving in water, so it has turned to volume. Trust me when I ask you to follow the line of this. It will help you, and that is the essence of coming here to come and learn all this stuff. So make sure you understand all these things. They are very simple to know. So the volume here is what was dissolved. So sometimes you see it in DMK, sometimes it may be in gram of water. So molality, not molarity. We still talk about that when we take concept by concept. So this is going to be divided by 100. So everybody knows how to divide. And I think 100 here at 1, 100 in 1,000 is 10. You are not good in dividing, just directly do your own thing. 20.2 times 10 is 202 divided by 101. 101 times 2 is 202. So this 2.0 moles per dm will be the answer to this guy with direct formula based. I hope you understand that. And this is the answer according to me. So next question. The next question says, a solid that absorbs water from the atmosphere and form an aqueous solution. Important thing is aqueous solution. So if you are talking about aqueous solution, you have to understand something. We talk about absorption and ability to absorb water of crystallization. Topic water of crystallization. Three phenomena are to be known in junior classes. The phenomena I hope you guys still remember are efflorescence. The second is the liquescence. And the third is hygroscopic. So these are the fundamental three things under that topic of water of crystallization. Numericals are also there, that is calculation. But one thing you just need to keep in mind is efflorescent substances are those that when exposed to air, they lost their water or crystallization. So that is just that about that. Whereby these two, or whereas this particular two absorbs water of crystallization, WOC. Now, they absorb, and that is why both of them can be used as what? Both deliquescent and hygroscopic can be used as a drying agent. Now, but the major thing that differentiates, there are a lot of examples because when I feed, I need to give you example. Example of inflorescence is your washing soda. Then it will lose water, then it form what? Caustic soda. Na2CO3 dot 10H2O. That is washing soda. 10 molecules of water. So when you expose to air, it's what? It reduces to 1, giving you caustic soda. So here we have the liquescent and hygroscopic as those that what can be used or can be used as a substitute of drying agent. Most hygroscopic substances are preferred to the liquescent. Excuse me. So one thing we need to keep in mind here is that hygroscopic substance absorb water that is not enough to form solution. So hygroscopic basically don't form solution when they are exposed to the atmosphere. A very good example is liquid H2L sulfur is a very good example of this. So H2L sulfur is a very good example of an hygroscopic substance, whereas the liquescent absorb and what forms what aqueous solution. It's a basic question which you might have studied before too. So now keep it in mind, those that absorb water crystallization to form aqueous solutions and the liquescent, whereas hydroscopy absorb water, it is not enough to form that. So we are going to go with this as the answer to that question. So I hope you understand that. It's a basic question, like I said, and we move to the third one. Fine. Now, the third one says a mixture of sand, ammonium chloride, and sodium chloride is best separated by dash. Now, under the topic of separation techniques, order of separation is important because if you don't follow the order of separation here, you might not end up separating them well, as you can see. So we might have studied that sublimation. We can talk about that. Sublimation is a technique that involves a direct movement of a substance from solid to gas or gas back to solid, as the case may be. So now there are a couple of examples of elements or compounds that behave like this. One of them is ammonium chloride. Ammonium chloride, very important, chlorides. We also have iodine crystals. Iodine crystals, crystals of iodine also sublime. Naphthalene, which you call camphor, dry ice can also form that, you know very well. So camphor, which is also called naphthalene, can also do that particular thing, naphthalene. So these are just important things you can keep in mind. Now, to know the order of how you're going to do this is also very important. Now, how are you going to do this is, well, fine. If this guy can sublime, allow sublimation to be the first process. So after sublimation, what do? This is sand and this is salt, as you can see. This guy is salt and this guy is sand. So the next process should have been you add water so as to filter off. Because if you want to do filtration, when you add water, what happened? You know what happened. Sodium chloride, and that you can't use evaporation because you want to filter. Sand will be the residue. You know that very well. So now the next process is sublimation. When you sublime, when ammonium chloride sublime, add water. When you add water, then you and filtrate. So note that add water, then when you add water, then you filtrate. Note that. So if we go by the order here, if you have add water first, then you filtrate, then you sublime. It's very wrong. If you add water, crystallization is out of it. Now look at B. Sublimation followed by addition of water, then evaporation. Now evaporation. If we evaporate this, salt normally can be separated by the method of evaporation, no problem. But we need to filtration. You know the knowledge of filtration, you have the residue and the filtrate. So if we filter off, then we'll be able to separate sand from sodium. So that is why I'm going for this, and that is why this is correct. The next one is a simple question, which because of time, I will have to be a little bit I would increase my pace. Now, solid substance usually melt, and this is fundamental question from very, very junior classes. When I say very, very junior classes, I mean from our basic classes. Now, solid substance do have high melting point. So that is one of the criteria for purity, high melting point. So when we talk about criteria for purity, pure substance, we look into their boiling point. I hope you still remember this basic stuff. We looked into their melting point. We also check their, sometimes we look into their refractive index or indices as the case may be. That's just singular and plural. So boiling, melting, then you can say solubility. So the rate of solubility, all these things are physical properties that you have studied in junior classes. So for a solid substance, they do have what? High melting point. So, and you know, effect of melting, effect of boiling, effect of pressure, effect of volume, and those things are also very important, though I will take them one by one. So for this one, a pure solid will melt over a what wide range of temperature should be correct, and this is the answer. Narrow range is at lower temperature, at same temperature as a pure one. No. So note that these are some criteria for purity, which you can keep in mind. So next one. Now the next question says a liquid begins to boil when dash. So liquid will boil when it atmospheric pressure is equals to vapor pressure. This is definition. We have also studied that about the movement of when we talk about the change in state of substances without changing temperature. That is latent heat and stuff. Kind of physics type of questions. So liquid boil or boiling point is the temperature at which the atmospheric pressure atmospheric pressure is equals to the vapor pressure. So don't let me waste time on something I believe you guys should know. And if you don't know it, so liquid boils at this particular condition. So because molecules try to escape the surface, the atmospheric is also trying to drop in. So the time when they set out the core at that particular point, we said it's going to form a kind of a thin layer on top of on the surface of the liquid. So that point we say boiling occurs. So molecules start escaping. It is when its vapor pressure equates the atmospheric pressure. And that time we say it's as boiled. I hope you understand that. So C is correct. The next question. Question 6. Now, question 6 says a gas sample with an initial volume of 3.25 decimeter cube is heated and allowed to expand to 9.75 decimeter cube at constant pressure. So that's just a constant thing. So we think about our thermodynamics or kinetic theory of gas. So when pressure is constant, everybody knows what comes to your mind first is Charles' law. So if you remember Charles' law numerical, when pressure is constant, the process is called isobaric process. Isobaric. So now at that point, the three thermodynamic process you keep in mind in junior classes are volume, which is denoted by V, pressure, which is denoted by P, and temperature, which is denoted by T. So this is the relationship we set in junior classes, and it is the basis of your ID gas. So, and if we say if gases are ID, remember, I'm not going to take too much, but I'm going to do concept video. PV is nRT. Now, when we make nR socket of a formula, this is always the gas law we follow, PV divided by T. This is the way we relate. So if pressure is out of it because it is constant. You are only having volume and temperature. So directly you say volume over temperature is constant. So you can take the phases, that is the change in one state to another state. So this is the way. So always keep this in mind. PV over T is valid for all what ID gases. Where N and R are constant, N is called the number of moles, R is called the molar gas constant, which I am not going into because these are direct questions you guys can solve. Now, directly you can just substitute values and say, fine, initial volume is V1. I take that as V1 as 30.25 pressure is constant. Then when it was heated, the volume expand, and we have a new volume I call V substrate 2, and that is 9.75 decimeter cube also. So we have, if we follow that, so now they now ask us that the ratio of the final temperature to the initial temperature. Why final temperature is T2? So I'm looking for ratio of T2 over T1. From this formula, it's the same thing as saying V2 over V1. As I have only transposed this formula. I have only transposed the formula. So there is nothing to solve because you can see here V1 is a V1 T2. Look at it, V1 T2. Because the question asks for T2 over V1 over T1. So the second volume from here is nothing but the second volume here is 9.75 divided by the first volume V1 is 3.25. And on simplification, the answer here is nothing but 3 over 1, which you can write as 3:1, or say 3:1. I hope you understand this, and this will make this correct for the questions that are admin. A is correct for the sixth question. The next question. Yes, the next question says two cylinders A and B each contains 30 centimeter cube of oxygen and nitrogen respectively. That is, there is oxygen and there is nitrogen inside a two-cylinder jar at the same temperature and pressure. So that is a pointer to something funny because the temperature and pressure is the same. So we can say the volume is the same, the temperature and the pressure is the same. So the law that states that at the same temperature and pressure is called what? Avogadro's law. I hope you still recall this from your junior classes. Now, from Avogadro's law, you should also remember that from Avogadro's law, we're told that what when two gases have equal volume at the same temperature and pressure, these two gases will always have or contain the same number of molecules. Remember, that is the number of moles. Though number of molecules might be different from number of moles. You can watch my physics kinetic theory of gas to see some derivation if you're an advanced level student on the physics channel. But keeping it simple here, the number of moles will be equal according to Avogadro's, which state you can recall that equal volumes of all gases at the same temperature and pressure contain the same number of molecules. So the number of molecules here is 5 moles of nitrogen. So if number of molecules of nitrogen is 5 moles or 5.0 moles, basically they are the same. It's the same thing as number of molecules of second gas here is oxygen. It will also be 5.0 moles. So that is just the concept, I think, that is hidden in this question. So they are going to have the same number of molecules. So when they have the same number of molecules, you expect them to have what? The same temperature and the same pressure. They are being carried out at the same temperature and the same pressure and also the same volume. That is just the law. Now, next, we can now say from our stoichiometry, we have also studied the numbers of mole or moles, depending, is the same thing as the mass given, the given mass over molecular mass, or you say the molar mass. Now, the question asks us to find the mass of oxygen. So mass, we are not giving mass in this case. We are looking the mass of oxygen. So looking for the mass of oxygen, the same number of moles, you can say 5 is equals to mass of oxygen. I will write MO over molar mass of oxygen. Even though it is not given, oxygen is O2. 16 twos are 36. You remember? Very good. So this is, you multiply 2 times 16, you're going to have 32. So this is 32. So on simplification, you cross multiply. And when you cross multiply, you're going to have your answer. That is 32 times 5, 160 as the mass of oxygen. So D is correct to this one. So we can also move to the next question. Now, fine. The next question says 1 mole of hydrocarbon contains 48 grams of carbon. So we can just put that in writing that a mole of a substance is the same thing as its molar mass. So 1 mole contains 48 grams, I write gram as G, of carbon. And definition, what we need is to know what hydrocarbon is. First thing. Hydrocarbon basically a substance that contains carbon and hydrogen. If its vapor density is 28, another important thing, vapor density is 28. Another concept from junior classes is that relative molecular mass, RMM, is equals to 2 times the vapor density. So the molecular mass of this guy will now be 2 times 28. Everybody can multiply 2 times 28. 28 twos are 56. So now, if we go by that, we have 56 gram per mole is the total molar mass of this guy. And you know from empirical formula times N must give you the molecular formula. And the molecular formula here is 56. And the question says we have to find the hydrocarbon. I think it's now easy from the way I've actually simplified it. So to get the hydrocarbon, 1 mole of this guy was said to be 48 plus, because it is in 1 mole of that substance, plus H, we don't know, let me just call it X, is equals to 56. On simplification, we can say X is equals to 56 minus 48. So if we go by 56 minus 48, X answer will be equals to 8. So we can say the hydrocarbon here is very simple to know now, because if 1 mole of this guy is 48, everybody know this guy, carbon. I don't know if you are following me. If you guys are following, it will be carbon because we have a carbon is 12. So you can actually see if you want to know the amount of carbon, because here I only try to calculate the amount of this. So number of mole is mass over molar mass for carbon. Number of moles, you can just follow what I'm doing is mass. We did that now, mass given divided by the molar mass. So if I do that, so mass of carbon is 48, 1 mole of carbon. Molar mass of carbon is 12. I hope students still remember 12 times 4 are 48. So this hydrocarbon can be C4. Then H, I want to get this now. Now, I will also use number of mole is number of mole of hydrogen. The same formula. I hope you are following. Is mass of hydrogen is 8. Molar mass of hydrogen is 1. Hydrogen is C. Please note that. Hydrogen is C. Hydrogen is H. Please note that. So I am actually using that as 8 over 1, which is 8. So the hydrocarbon is C4, then H8. C4H8. So if you have C4H8, please keep it in mind. It will be what? The one that has a general formula of CnH2n, which is your alkanes, which they're also called olefins. Alkanes have general formula of CnH2n plus 2. Please, there are a lot to learn. These are basic chemistry. I told you is observation. Alkanes is CnH2n. Alkynes is CnH2n minus 2. Then aromatic obeys what we call the Ucker's rule. So Ucker's rule, that is 4n plus 2 pi. So that is at least an aromatic substance must have at least 1 benzene ring in its structure. So if you watch C4H8, which is what we have gotten from our calculation, it obeys the general formula of this. When n is 4, 2 times 4 is 8. So we pick this as the answer to the admin question. So that is the answer to the question given by the admin. So we move to the next question. But the next question says, the general formula of alkanones is dash. Now, a quick concept about alkanones. Now, alkanones are product of oxidation. They are formed by oxidations, elementary stuff of secondary alkane. In your physical chemistry or inorganic chemistry, you've also studied what we call oxidation in terms of addition of oxygen and the removal of hydrogen. So basically, alkanols, or you say alcohol, the way it's being called, are grouped into 3. They are classified into 3: primary, secondary, and tertiary. So if you oxidize primary alkanol, you are going to have alkanals, a quick concept. And if you do secondary, you are going to have alkanone. So and tertiary, it cannot be further oxidized. So now functional group are good to know in chemistry. This is OH, and this is why they said alkanols are like a base because of the presence of OH. Now, we are not into nucleophile and electrophile. I will have explained some things here, but with these basic questions, let's take it basically too. Now, alkanals are generally CHO. This is their functional group. They are also known as aldehyde, in case you want to know more. Then alkanones have a RC, we have a RCO. CO is their functional group. And we also have alkanoate for more because of other question alkanoate. They are also called esters, sweet odor, RCOOR dash. So that is their functional group. And we have alkanoic acid, which is also called carboxylic acid. Those ones are COOH. You can draw their bond. Hope you know O bond is always double bond. You understand that double covalent bond are formed from O. So basically, I think this is a direct question. B is correct for this, and nothing to waste time on. This is the answer to that. So basic questions require basic explanation. So, and this is the way you can actually get to know answers to chemistry, observation, practice, and knowing them. It's always important to keep it in mind and do more practice. And this is why I'm going to help you guys taking them line by line, chapter by chapter. This is just the first video. Stay with us here and we're going to see more. The next question is question 10. And question 10 says, when sodium ethanoate, we just talked about alkanoate, esters now, CO. So if you want to write sodium ethanoate, you are going to have the functional group of alkanoate now. Ethanoate is COO. Sodium is Na. This is the way we write. The metal is going to be at the back. Then you said ethanol. Ethanol means two carbon. One carbon has come from the functional group. So you have to what? Add the methyl. So you have CH3. So alkyl, this is 1, 2. As you can see, 2 carbon is ethanoate because of functional group CO. So sodium is at the back, which is we pronounce sodium, then 2 carbon, ethanoate. Is treated with a few drops of concentrated H2SO4. I think this is simple for us to, organic chemistry reactions are simple to react. So what happens is this, this is plus, this is minus. This guy come here to carry hydrogen. So we have CH3, COOH plus, what do you have? You have Na2SO4. So this is the product you are having. And if this is the product you are having, the question now says one of the products is dash. So this guy is called alkanoic acid. This is alkanoic acid because of the functional group. If you want to call it how many carbons? 2. So you now call it ethanoic acid, which is popular everywhere. So that's ethanoic acid, and that is one of the products from. The other product is a salt, which is sodium tetrasulfate 6. So next question to that should be question 11. Now, question 11 says, which of the following reagents will confirm the presence of unsaturation in a compound? Basic question require basic explanation, like I do say. So now here you can say, if we talk about saturated and unsaturated compounds, we can take ourselves back to alkanes, alkenes, and alkynes. Alkanes, single bond, alkanes, double bond, and alkynes, triple bond. So now, alkanes, alkenes, alkynes, we now said these two guys are unsaturated. Why? From our knowledge of hybridization, we can explain that carbon is tetravalent. If we say it forms 4 equal covalent bonds. Yes, you know that. Now, and the carbon-carbon chain in them are sp3 hybridized. We might talk about that later in alkanes generally because it is saturated. So what are we trying to say here is for saturated compound, the hybridization form there is sp3. sp3 will tell you the shape of that particular substance. So sp3 introduce you to know that what the shape is tetrahedral. Now, in this one, they are unsaturated because there is a double bond. You know this. So we say the hybridization here is sp2, and sp2 also gives you to what we call a kind of shape you can pick in mind. We call it triagonal planar. So you can always keep that in mind. That is the geometry of that. So this is triagonal planar, triagonal planar, or planar, anyhow you call it. This is tetrahedral, talking about hybridization rule. And when it is triple bonds, it's more like a straight line. So the hybridization is a sp. So an sp giving you a straight line, that is a linear shape, more like a CO2 in your physical chemistry. So these are things you can keep in mind. So, and this can also let you know the bond angle and stuff like that. We say the bond angle of alkanes or methane as the first family of these, which is popular methane. Quick concept is 109.23. For this one, we say it is about 120 approximately, and this guy is a straight line. You think about 180 degree. So that is important thing about understanding saturation and unsaturation of the first family, introduction to organic chemistry or hydrocarbon, saturated, unsaturated, aliphatic, and aromatic. Hooker's rule. We'll talk about that if we see questions. Now, which of the following reagents will confirm the presence of unsaturated? That is alkanes and alkynes. So if you want to test that, because these don't have vacant shell or vacant space, vacant orbitals, because there is no vacant orbitals in them, they don't undergo reactions. Most of the reaction common to them is what? The popular reactions of all hydrocarbon. When I say popular reaction of all hydrocarbon, you guys should know the reaction I'm talking about. That is combustion reaction. So combustion reaction is common to all hydrocarbon. So, and also they undergo a kind of reaction also, which is substitution in the presence of light. Basic thing, observation is very important. Ultraviolet ray of light is the catalyst during this. Then you can talk about the reaction mechanism if it is needed, but I think for your level, post-UTME, those things are not needed. So for JUPEB and A-level students, you can stay on this page because I'm going to be taking line by line on the chemistry chapter wise by the grace of God. So not to waste our time. So basic reagents can actually test for saturation and unsaturation. Basic reagent like potassium permanganate, KMNO4. I hope you know the color. Now then K2Cr2O7 can also do that. Another important reagent is bromine water. Bromine water can also do that. Apart from bromine water, you can also use another reagent called Grignard reagent. This also can also do that. So keep that in mind. All these can actually do, because my dear saturated alkanes will not react. It is only the alkanes and alkynes that have effect. They colorize the purple color of the KMNO4, change the color of K2Cr2O7 from orange to green. You know bromine is red. Everybody knows under the concept of halogen and compound. Then also Grignard reagent is a mixture of what we said is a mixture of alkyl with magnesium. Don't worry about that. I'll still break it down for you later with halogen. So it's what an alkyl with a metal plus iodine is called Grignard reagent. So all these are used basically to test for what we call unsaturation. So be careful about that. The answer to that is bromine water here. This is the right answer to the question. Bromine water will confirm that. Then you can ask, what are these reagents also used for? Because it's important to have an idea about that. Because if you have a very good idea about something, you become master of it. Now, this reagent Ferlin solution is very important. You guys might have studied it. Now, we use it basically to differentiate between alkanone, that is the one I talked about, oxidation of alkanol, and alkana. So one of the fundamental usage is this, which is also what the same thing we use tolerance reagent also to do. So both tolerance reagent and Ferlin solution can differentiate between these two guys. So note that, whereby Benedict will take you to your food test. For those of you remember biologic class, Benedict, Burex test, xanthoperic test for protein, to mention but few. So keep that in mind. Ferlin solution can also be used to test for carbohydrate. There are different types of sugar, simple sugar, and complex sugar. So line by line explanation, which I will do soon by the grace of God, will take you guys there. Don't worry, chemistry is observation and practice. When you practice it more, you are going to know it better. question next is 12. Fine. The 12th question says the caustic soda solution in a conical flask serves to dash. So to dry ethene gas, remove carbon dioxide from ethene. Okay, fine. Now, in this type of question, it is actually testing us about the knowledge of preparation of ethanol, which is a C2H5OH from ethene, which is C2H4. So that is what this question is actually asking us to us, or trying to test us on. So if we want to follow the line of this question, if we try to prepare, we do this in the laboratory by dissolving or reacting ethene. Ethene is reacted with H2SO4. Then inside that preparation in our conical flask, the setup whereby we use our delivery tube to connect different stuff together. So as we mix H2SO4 with ethene, we have a flask, which we pass the pipe into. That first flask always contain we have inside it, we use our caustic soda. So this caustic soda, say soda ash. Now this caustic soda serves as a remover. Let me just write it in a simple language. It removes as a remover of ethene impurities. Definitely impurities are going to be in a substance, that. So, and when you are preparing a particular compound, either organic or inorganic compounds, you must try to make it pure. That is one thing, first law. So if you know that as your first law, so to remove impurity, removal of impurity, any way to sound like that, or caustic soda, the impurities we now talk about are, in preparation of this from ethene, are what we call SO2. And another one is carbon dioxide. These are the major impurity forms. So these are the impurity forms during the preparation. You keep it in mind to this observation. In fact, if we prepare alkynes too, we also have impurities. That one is called phosphine impurities. These are things, right? That's why I told you chemistry is more of observation, so you don't need to waste your time. So dry ethene gas, caustic soda is not a drying agent for ethene gas during preparation. In fact, it is not put in conical flask to dry ethene. So now, remove carbon dioxide from ethene is correct. This is the answer for what I said. Carbon dioxide is an impurity form, and it's remove it. Then we said remove sulfur oxide from ethene. No, sulfur oxide from ethene. So major impurities are SO2 and CO2. In fact, CO2 is said to be the major impurities and not SO2. So SO2 is also the impurity form. So you can also keep that at the back of your mind. So the next question. The next question is question on hybridization, I think. Which of the following orbitals of carbon are mixed with hydrogen in methane? So I think we've talked about hybridization not quite long. Methane is written as CH4, single bond, also known as paraffin. Alkanes are called paraffin. So, but let's do most of alkane or methane are used as a domestic fuel or fuels, if you want to write it. We've talked a lot about this. We don't need to start talking about alkane again. So now, if we draw the structure of carbon and hydrogen, you just need to see this is the carbon. You can see this is the way we do it. Then we draw the center. So we say it is sp3 hybridized. We talk about that. Now, carbon forming a 4 covalent bond, 4 equal covalent bond. So according to law of hybridization, which I believe you have studied, if you have not studied Hund's law, it's very important for you to know. Talking about movement of orbital hybridization, when you move, you can move. For example, carbon is number 6, 1s2, 2s2, 2p2. I hope I am right. Carbon is number 6 in your periodic table. You know this. So if you draw the normal way, 1s fill 2s. Now, if we now movement orbital hybridization is the movement of one particular orbit to the other to complete. Now, if you have this one, if you now move the 2 carbon here, the 2s2 here that's available here, you are now moving into the p orbital. We say 1s2, 2s2, then the 2p2. So if we move this one, the single, we now move it. We separate this one, then we have 1. We have the second one, 2. Then we now move the 2 here to have 3 and 4. That is how we come about the 4 equal covalent by orbital hybridization. So my point is, always keep it in mind, hydrogen is always in the 1s because it's the first word, it's number 1. So it is always in the 1s. Please note that. So whereby the 4 covalent bond of carbon is formed between carbon-carbon exists as a between hybridization between the 2s orbital and the 2p orbital. I hope students know s orbital can take maximum of 2, p orbital can take maximum of 6. So carbon and carbon. So the hybridization occur between what I'm trying to explain between two carbons. This thing is between the 2s orbital and the 2p orbital. Whereas carbon and hydrogen occur, carbon and hydrogen, that is what you are asking. Hydrogen always fall to the s shell, the first one s shell. It is when you get to the what to the p shell, you now talk about the diagonal relationship, talking about the x, the y, and the z, and the z orbital arrangement. You know, the 1s is just a single lobe, just a single lobe. When I say single lobe, I mean it's just only stand like this. It's a lobe like this, just a single lobe like this. It's not going anywhere. So it's a single lobe like this. So that is talking about orbital, the exact position of what? Of a particular electron in an orbit. So that is what we call orbital. So they can be moved around from the law of Linus, from the law of Ohm's and Harvard principle, if you have studied that. So what I'm trying to say is that the hydrogen orbit is always 1s. It doesn't pass that. But the carbon is what is at the 2s. Please note that. So when we talk about the knowledge of hybridization, which I'm still going to take you line by line, keep it in mind. Here questions say the carbon and hydrogen in methane. So carbon is at the 2s orbit. How did I know? You can try to draw out from number 3, like I told you, carbonic number 3, you can see 1s2, 2s2, 2p2. So the carbon and carbon are always between the 2s and the 2p. That is where it falls to. Whereby hydrogen as the first member is just 1s1. You can see. So that is what s. So x is the orbital orientation of hydrogen, whereby 2s is the orbital orientation of carbon in methane. Please note that. But if I go to the next one and I have 2 carbon now, you know, it's a kind of different thing now. So I'm having 2 carbon, the first one and the second one. It will be 2s and the 2p. So please note that. So my point here is that the answer to this question is hydrogen 1s and carbon is the 2s. So that is what the question asks, not between 2 carbon, but between the carbon and hydrogen. So that's the answer. So next question is question 14. Question 14 asks us about which of the following reaction occurs at the anode during the electrolysis of dilute sodium chloride, even though we are not given what is called the electrode that is used. We just assume that it is just a normal electrode, a cheap electrode, which can be carbon electrode or any other electrode that is cheap, or platinum electrode, or when you say they call it inert electrode. Now, electrolysis of dilute HCl, or what are we doing? Is it HCl? Sodium chloride, NaCl, dilute. So if we electrolyte dilute NaCl, there are 2 compartments, electrolysis method. Na plus, let's be fast, and the Cl minus. So then we dissolve in water method, H plus and OH minus. So nothing to solve here, like I do tell you. So here, this is cation moves to the cathode. Oxidation takes place at the anode. Reduction takes place at the cathode. Per Hoc NCl. This is the logic. Positive anode oxidation, negative cathode reduction. Positive anode. So anode is positive oxidation, negative cathode reduction. Oil rig. Oxidation is loss, reduction is gain. Oxidation is loss, reduction is gain. So directly here and the cathode, this guy, because it is a dilute solution, there are factors that affect discharge of ion during electrolysis. I said I'll do line by line explanation to these different topics. Don't worry, by the grace of God. So dilute solution, we are talking about dilute solution. So concentration of the ion. Concentration is inversely proportional. Please note that to what is going to be discharged. Now, so far it is dilute, you know, there are 3 factors that affect the discharge of ion. Maybe I talked about it. position of the ion or ions rather in the electrochemical series. Then, like I said, we are not talking about the electrode. So the nature of electrode that is used. And the last factor is the last one I've written, concentration of the ion. So these are the three major factors that affect the discharge of ion during electrolysis. So here it is a dilute solution. Because it's a dilute solution, what you expect is that at this compartment, which is what the question asks us, anode, instead of oxygen to be discharged, it is this chlorine that will be discharged because it is a dilute solution. So the concentration of this is less. So you expect Cl minus E minus to give you Cl. So Cl plus Cl will now give you Cl2 to be discharged. So this is what you expect. Oxygen is not discharged, it's chlorine gas that is discharged. So I'll go for that. So please, that's the answer to the question. I have to increase the pace. I'm not even at the midpoint of the question. The next one says, I hope you can hear. Now, the next one says, this is ammonia. Ammonia is a base. I hope students know that. Combining with ozonium ion, ammonia plus hydrozonium ion, H3O plus, is giving us ammonium plus water. So the question asks, it may be deduced from this reaction above that dash a redox reaction has occurred. This is not a redox reaction because if you have, if you can recall the concept of your acid, base, and salt, concept of acids, bases, and salt, you were told that any substance, now this is take to be an acid. This is an acid. In fact, we call it a Bronsted-Lowry acid. Why is it a Bronsted-Lowry acid? You know, we talk about proton donor, proton donor, proton donor, plus it has donated this guy, H has donated and forming what? Water. So this is an acid because it is called what? A proton donor. Proton donor. Proton is positively charged. Proton donor is called what? An acid. Whereby a proton acceptor, look at this guy, H3 has accepted the proton here to become NH4. So now it's now called a what? A Bronsted-Lowry base. Proton acceptor. Accept. So it's called a base. That is a base. So I hope you guys are getting this. Chemistry is observation, like I said. It is more of observation than cramming and understanding. You can understand chemistry. I don't know, admin, what happened to my writing part. Okay, fine. I think I can still manage it. Now, this is base when it accepts, and that is why this guy is a base, because it has accepted to form this, and this guy has released. Is an acid to form this. I hope students understand. So this is base. So, and this is definition of Bronsted-Lowry acid and base. Whereas another definition is Lewis. You guys know Lewis. Lewis very well. Lewis is a popular man. He was even the man that first gave us or first discover, I think, deuterium oxide. I think you guys, I've told you guys before, deuterium oxide, heavy water, D2O, under the concept of isotopes. So, and also took a lot of accolade under the concept of former charge and the position of Lewis structure, dot structure, to actually know the number of particle that is reacting, number of electron, how to draw the structure of a particular element or something. So you know Lewis. So also under the concept of acid, Lewis also defined acid as this is now electron pair donor, electron pair acceptor. By base is the opposite, electron pair donor. It's just the opposite of this one. So when acid is proton donor, so it will be electron acceptor. Do you understand? Just word and opposite, nothing more fancy. And also, you can also think about conjugate acid and conjugate base. That is when look at this one. This guy, this is look at this one. This is an acid. Ammonium is an acid. It dissolves in water now. It's forming us what? A base. So that is the concept of conjugate base. and conjugate acid. So these are simple things. So it's a simple question. We are talking about H3O acts as an oxidizing agent, doesn't make sense. H3O as an acid, I think we've talked about that. And this will be the valid answer to our new question. So I think we can move. The next one is the question says 4.0 gram of sodium hydroxide is NaOH. You guys know sodium hydroxide very well. In 250 centimeter cube of solution, what up? This is an incomplete question, but because I'm saying this is molarity. So molarity of a solution is written as C. Now, you know the simplest formula N equals to C, because some of you might think, what am I writing? If you are not used to the way I want to define. So it's the number of mole of solute over volume of solute. So that is the molarity of the substance, which is called the concentration as well. So number of mole. You also have molality, which is number of mole of solute over what? Over the weight of the solvents. Don't worry about molality now, because I think it is not required for post-UTM students. Now, we can now solve this one and by saying the number of mole over this. Then in this case, you can see two unknowns we don't know. We don't know the number of mole. So also, we just study not quite know the number of mole of a substance is the mass given for over molar mass of sodium hydroxide. It should be 40 grams. Sodium is 23 plus 16 plus 1. So that is how I come over 40. 4 over 40, that is 1 over 10, is 0.1 moles. So that is the number of mole. So number of mole is now 0.1. I am continuing here. Is 0.1 divided by the volume of the substance is 250 centimeter cube. If you watch, you can see. So we say the amount that is dissolved in 1,000. So you have to convert this one to decimeter cube. So by dividing by 1,000. So if I say 250 over 4, it's not a problem. So most students say N equals to CV. Say N is now equals to 250 over, I say over 4 over 1,000. Here is the 4 coming from. So 250 over 1,000. I hope you understand 1,000 because I have converted to decimeter. So it's 0.1 divided by, that would be times, let me just do the solution, 1,000 over 250, because we don't have calculator here. Here 1, here 4. 4 times 0.1, that is 0.4 moles per dm cube. So that's the concentration, is what the question wants us to calculate. And that's the answer to that question. So this is the answer to it. I hope you guys are getting this. The next is question 17. Now, 17 says, during electrolysis of a salt of metal M, a current of 0.5 ampere flows for 32 minutes 10 seconds and deposits 0.325 grams of air. What is the charge on this metal, on the metal? Concept of electrolysis also tested here, I guess. And to solve this one, I think it's formula-based question. So when you have formula-based question, you don't need to waste your time. Apply the formula if you know it. And if you don't know it, under the second law of Faraday, law of electrolysis, the second law says the mass is equals to relative molecular mass times the quantity of electricity. Divide that one by the charge, multiply by the Faraday, which is a constant. So you can keep a formula-based question like this as simple to solve. Second law said that if the same quantity of electricity pass through different electrolytes. So now we say 1 Faraday is 96,500. So I need to also understand from quantity of electricity is current times time. Everybody should note this. It's also one of the most fundamental formula that is important. So Q is IT. So I need to get my I and T to get Q. I current is 0.5 from question, and T should be in seconds, 32, 10 seconds. So 32 minutes is 60 minutes make 1 hour. 60 seconds make 1 minute. So 60 times 32 is what I'm going to do here. 60 30s are 1/8, 62s are 120. 1/8 plus 120 should be 1920. So sorry about that, guys. I just want to increase the pace. So 1920, 0.5 times 1920. It's like dividing 1920 by 2. So if I divide 19 by 2, 2 times 9 are 18. That's 9. 2 times 9 are 18. 2 times 6 are 12. And this is 5. I hope I am correct. 965 is 0.5 times this. Let's say 2 times 9 are 18. 2 times 9 are 18. Remain 1. 2 times 6 are 12. So remain 0. So it should be 960. So 960. 960. So 960 is the quantity in coulombs, which I don't even need. The mass it was that it's deposited was this is 0.325. 0.325 is equals to the relative molecular mass of this substance M. It should be given in bracket. It was 65 according to the admin. Multiplied by this guy, we solve 960. We are looking for the charge on it. The Faraday is constant 96,500. So here I think I'm going to make calculator, but before that, I was thinking this should be 965 so that we cancel each other. I don't know why it is not 965. So 960 times. So maybe I made a mistake in conversion. 32 times 60 is 1920. Because I'm thinking this should cancel this and this will go, but it's not going like that. So here I can say C answer directly can be given as C is equals to here from making C sort of formula when I cross multiply. So this is 0.325. Wow. That should be equals to 65 times 96 divided by 0.325 times 965. So I will have an approximate answer. I should have a calculator here, but it's just because I'm lazy to bring it out. But let me just bring it out because, but in PostUTM, if you don't have calculator, you can still get an approximate answer. That's why I'm saying this guy is very close to 10. So you can see it's very close to 10 of this because this is 960. It's more than 10, but it's very close to 10. I hope you understand my concept. So because it's very close to 10, you can say year 1, year 10. So this is like 6.5. So 65 in 325 is what you just want to do. So by calculation, you can know. So I can say here the answer will be about 4. I'm thinking about 4, but let me see if I can do that. I have a calculator here. Hopefully it will come out quickly. I don't want to waste time for you guys to just see what I'm talking about. Let me bring the calculator on the screen for ease of access. Calculator, please come up. So while calculator is coming up, you guys can press this and actually see what would be the answer to the question. I don't think this one should give us any problem. The calculator is loading. I think it's wasting my time, and I will need to move on to the next question because I don't have that time. I don't have that time to be wasting. Calculator, please come up in 30 seconds. If you're not coming, I will leave you guys to drop answer to this one on the comment section. Well, it's not coming. I think I have to move on. Okay, now it is. Yeah, we have the calculator. I hope it is visible to you guys. This is 65 multiplied by 96, 6240.325, 0.3. This one cannot press point. I have to press 0.325 times 965. 313.625. 313.625. 6240 divided by 313.625. Just hope I don't make any mistake. This is 19, which is out of it. So I don't know, maybe there's a mistake somewhere. So that should be what you guys are going to do on your own. Yes, yes, yes. 60 times 32. I'm not going to waste time on what I think is just an error. 1920. So 1920. Oh, this is 9650. That is where the mistake is from. 9650. So that's my mistake, guys. So 65 times this one. 65 times 96. 6240. 6240 is 0.325 times 9650. So 3136.25. 3136.25. 6240 divided by 3136. 3136.25. I know very well. The answer is true. Yeah, 1.998, whatever. So approximate answer is what we need, which is true. So the answer to the question is true, and that is option B. So I only want to provide the answer to our question. That is why I'm keen on solving them. Excuse me. Now, the next one says, which of the following is a property of ionic chlorides? Ionic chlorides. They can be decomposed by heat. Now, most ionic chlorides are not decomposed by heat. You need to keep in mind. They react with aqueous AgNO3 to give a white precipitate that is soluble here. So note that ionic chloride, most ionic chloride combine with silver nitrate to give a white precipitate, which is soluble. Chloride, ionic chloride. So what we call ionic chloride, that's another thing. You know it's a chloride. So but it must be what undergo what we call a kind of what? Ionic bond. So ionic bond chloride, chloride over that is metal chloride. So you can just keep that metal chloride because most metal undergo ionic or electrovalent bond. So metal chlorides, most metal chlorides. So note that most metal chlorides react with AgNO3 to give you white PPT soluble in ammonia. So that's one characteristic of most metal chloride, which we call FeCl2. They are just think of a metal, NaCl. You can think of NaCl. You can think of any metal, KCl, potassium chloride. You can think of any metal chloride. This react it with see, if I say NaCl, for example, plus AgNO3, you are going to see this is the white precipitate of silver chloride, AgCl2 plus, you can see NaNO3. So this AgCl2, wow, this come up. This AgCl2 is what we are talking about as the white precipitate of silver chloride, which is soluble in excess ammonia. So the answer to that one is this. Let's move on because of time. Question 19. Question 19 says, which of these salts will produce its metals, oxygen, and nitrogen oxide? That is metal when it decompose, oxygen, that is O2, and NO2. So important thing is let's just take silver triisocarbonate 4. Yes, that's the answer. Silver triisocarbonate 4 is decomposed by it. I said triisocarbonate, triisonitrate, AgNO3. Talk about it now. It's going to give you silver, that is plus heat, silver solid, plus NO2, plus NO2 is gas, plus O2 is also gas. This is what this is going to what give you. Please note that. Sodium triisonitrate. Now, calcium. Now, most group 1 and group 2 nitrate. Nitrate of group 1 and group 2. You can just give it a mic. Group 1 and group 2. Nitrate of group 1 and group 2 will always yield metal oxide plus oxygen plus NO2. So that is what they do. Look at this now. Calcium CaNO3 all twice. Calcium nitrate will give you calcium oxide plus NO2 plus O2. So most group 2 and group 1 will definitely of nitrate of group 2 and group 1 will give you metal oxide. The question asks you to look for the one that give you a metal, oxygen, and nitrogen oxide. So because of that, this is the answer to that. I hope students understand the concept. It's a simple thing of observation and experiment. So the next is question 20. Now, question 20 says an experiment produces a gaseous mixture of CO2 and CO, carbon monoxide and carbon dioxide. In order to obtain pure CO2 or pure CO from the gas mixture, there's a mixture of carbon dioxide plus carbon monoxide. They are mixed together. Now, you now want to obtain a pure carbon monoxide. That is what we want to obtain. So the method here is just to what? To do this one from a mixture of the air, that is separation. So you can look for a drying agent that is going to dry up CO2, and you are going to leave with what? Left with what? And there are different methods we can perform, we can use when we are doing this in what? In chemistry lab. One of the fundamental knowledge we use is what? We use NaOH to dry CO2. So the solution of NaOH, so it should be a solution NaOH that is dissolved in a particular what, maybe in water. So solution of NaOH will dry CO2. So it's a drying agent. So when CO2 is dried, you are left with CO, which is what you want. Another thing is what? Now, another way is if you dissolve CO2 in water, it will dissolve, though both of them are sparingly soluble in water. So if we bubble CO2 the mixture through water, this will go down, then we get this. You can also dissolve them in water, which is also another way. So dissolving in H2O also can make you what? Dissolve CO2 and you obtain CO. So here you just feed through, passing them through heated copper cannot have any effect. H2SO4 cannot be used to dry carbon dioxide because they are both acid. CO2 is an acid anhydride. Please note that. The next one is bubble through sodium hydroxide solution is correct. Then bubble through water, you can say, now fine. Bubble through water is also correct, but it should the bubble through the solution through water and eat. So I will go for C because it's the best way to absorb and to obtain a pure, because the question says pure. So pure means the one that does not even have any CO2 in it. So the right answer to this is choice C, and that is why we are picking that. I hope students get that. The next is 21. Admin is giving a hand to increase the pace. Now the next one says in the active reducing agent, another important word is active. In the blast furnace of the extraction of iron. Iron is extracted in this blast furnace from ore. The ore of iron is hematite. We use hematite, which is color red. How do I know? A, hemoglobin. You understand? That is color red. And magnetite. This hematite is Fe2O3. And the other one is magnetite. That is Fe3O4. So, but mostly this is what we use. All contain a lot of impurity. You guys know that. I told you one thing about chemistry or chemist or whatever, or alchemist, the way we call them, is to make sure that what impurities are being washed away. So the impurities in this one is reduced by reacting hematite, Fe2O3, with carbon monoxide. That is the first step. And the raw material you have studied is calcium carbonate, which we dissolve, which will decompose to be CaO plus CO2. You know that. This CO2 will react with what is formed here after removal of impurity to get pure pig iron. Pig iron is produced directly from the furnace, then it is washed. This CO will react with another impurities of silicate to form slag, CaSiO3. Don't worry, line by line explanation, I will tell more about this. Now, note there are two major uh what's it called, two major impurities, which is being removed, or this act like a reducing agent. This is a reducing agent because when it reacts with this, we said addition of oxygen is oxidation. This is removal of oxygen. This will remove oxygen and reduce this. This will remove oxygen. So this will act as a reducing agent because there is what a decrease in oxidation state. And that one is better. So we have two particular substances that act as a reducing agent. It can be what? Carbon also, we also react Fe2O3 with carbon. This is also a reducing agent. But the most active reducing agent in furnace is carbon monoxide. That is what I want to talk about because I'm rushing now and because of our time. So I think, do you have that? Okay, fine. This is the answer to that. So this is the active reducing agent because CO acts with Fe2O3 then to remove the impurities of Fe2O3. So the next one is 22. 22 says, when dilute aqueous solution of lead-2 lead-2 nitrate, that's PbNO3 all twice, lead-2. And potassium bromide is KBr, and mixed. The precipitate is observed. It's simple to write. This is PbBr2 plus KNO3. So this is what is formed. This is solid, whereby the rest are aqueous. So note that. Now, the question is, we are looking for reaction, which is simple. Oh, this is it. Answer to that. I hope students can do normal reaction. The next is 23. Bronze is an alloy of dash. An alloy, about alloy, I'm going to do that one also chapter-wise. We can keep bronze and brass and major brass and bronze. I hope students still remember they are formed from tin. Both of them contain tin. So please add tin and I said tin and lead. and tin and zinc. These are the major elements there. There are other elements like nickel, like copper. Please note that I said tin and lead. I don't even know what happened to me. Copper is common to both. Cu, copper and tin for this, and copper and zinc. So apologies about that. So that is that. You just need to be careful. Copper is common to both of them. So other element in them is I'm talking about soft soda. Other major element in them apart from copper, and this guy has tin and this guy has zinc. So copper and tin is the major alloy of bonds. So you can just keep that at the back of your mind. And silver and copper is one. This is one. Copper and tin. This is the answer to that. Whereas brass is copper and zinc. So the next question, because of our time, there are other alloys I should have given examples. Let's move. Fine. The next one says copper metal will react with concentrated trioxonitrate 5 acid. This is also reaction question. So this is one of the methods under the concept of nitrogen and its compound. So we want to prepare nitrogen 4 oxide NO2. We use this method. That is copper nitrate CuNO3 all twice with concentrated H2SO4. So guys should keep it in mind. It's going to give you CuSO4, copper sulfate plus water plus NO2. Please note that NO2 is discharged. This is the gas that is being discharged. This is how we prepare NO2. This is a question of reaction which you can balance. So I don't think we should waste our time. So no, 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 no. This is prepared by decomposition reaction. If you want to prepare NO, nitrogen oxide, it is by decomposition reaction of ammonium dioxynitrate 5. This is what I'm talking about. If you decompose NH4, NO3, that is it. So you are going to remove water, H2O. How many mole of water? 2. This is 4 mole. Put 2 here. So the remainder is what you are going to write. 4H has gone, NO2. O2, O2 has gone, remain 1 O, then you have N2, then O. So this is how you prepare your laughing gas by the composition of ammonium triisonitrate 5. So this is a direct question, which I don't think I have to waste your time on, because it's direct, because it's simple, and because it's straightforward. So guys, let's move to the next question. The next question is next one. Now, fine. How many structural isomers can be written from bromide? In fact, we are given C4H9Br. So the best way to get structural isomer of what we call bromide or bromo, or what we say alloalkanes, for alloalkanes. The isomer of alloalkanes. Allo means halogen. The method we use is a simple method of drawing them, but this is simple to know because we can just draw them out. We can type, this is bromo. You have 1,1 bromo, bromo, 1,1 bromo. This is 4. 4 is butane. 1,1 bromo butane. Then we have 1,2 bromo butane. Then we have 1,1 dibromo. Then I've shifted one now. 1,1 dibromo. That is a dibromo propane. Then we have 1,2 dibromo propane. So what I'm trying to say is that there are 4 structural isomers of this. 4 structural isomers. You can draw it. Isomers to see how do you draw. Just draw the structure, then start shifting. So if you put the first one to be 1, 1, 1, you can see 1, 1, 1, 1 dash, you have dash. Say, let me just start with the 1. You say bromo butane, or 1 bromo butane. Then that is 1 bromo butane. Then you have 2 bromo butane. You can draw. Just trying to let you see what I'm trying to visualize from my brain. Then when you now put 1, 1, then it will now be, dibromo. Then you have shifted this one by 1. It's reduced by 1. What do you have now? Before butane, what do you have? That is propane. I hope you understand. Then this is 1, 2. Then it will be dash dibromo dibromopropane. So these are the four isomers that is possible. Because if you try to shift one, it will not complete again. So that is why by drawing it out, you can actually get this, which is the best method to draw it out. But it's simple to know alkyl halides are always mostly the number of carbon chain that is in them is always their number of isomer. That's another shortcut I can teach you. So for most alkyl halides between 1 and 5. Or if it is more than 5, it can be more than that. So keep that in mind. So now I will take 4 as the answer. In fact, this one now is symmetrical because I can draw this thing in two. I think yes, it's symmetrical. It's an enantiomer, but it's above your level. I'm not going to talk about that for now. So this is the answer. This is the answers for that. Let's take the next question. The next question says the final product of the reaction between methane and chlorine in the presence of UV light. We talk about that. That is tetrachloromethane. We talk about alkane substitution reaction. Final product is CCl4. So that is that. Let's move to the next one. I don't want to waste time because there is no more time. How many grams of bromine will be required to completely react with 10 grams of propane, gram of bromine? Now, let's just write bromine is Br2. You and I know, yeah, bromine. All gases are divalent except the noble gases. Note that exception. Now, how many grams of bromine will be required to complete the reaction of 10 grams of propane? Propane is C3H4. I've given you the general formula in the beginning of this slide for alkynes, CnH2n minus 2. So propane is 3. 3 twos are 6. 6 minus 2s are 4. So you can just draw that. It is now reacting with bromine, Br2 to give you one product. It's simple to know. Now, the knowledge of Markov-Nikov rule and whatever, which I'm not talking about here, is that the triple bond, this guy is a triple bond, will break. You can draw C3H4, C1, 3, H4. So C3H4, you can see 1, 2, 3. And this guy will complete. We put it here because this place has been completed. Just for you to see what I'm talking about. Nothing more pretentious. So C3H4, you guys know this is already completed. You can see that this is already completed. That's why I'm canceling that. So my H will be at this guy. I hope you understand. Carbon is tetravalent, and this guy is completed at the middle, and this guy will complete his H. You may not show it, but for you to see. So that's what we are talking. This is a normal way you draw your own your propine. I hope you understand. It's not combining with Br2. So because of that, I will just people will bring to double, double will bring to single. Nobody have time to be showing you all those time. Time is not on my side. This is it. Then bromine is 2. Then the rest we take now. Bromine is 2 in the first time. Then the second reaction, another 2, will now give you 4 of bromine. So I have to balance the equation. You understand? I'm supposed to tell you single, triple will break to double, then double will break to single. I will take line by line explanation on Markov-Nikov and anti-Markov-Nikov rule. So here I can say this we take here, and this guy we take here. Then the rest will be hydrogen. I hope you understand. So just for you to see, because if I write the reaction like that, it'd be like, how did I come about that? As you can see, so it should be 1, 1, 2, 2 if you want to name it, which I don't need the name. So just for you to see the product that is going to be formed. So the product that is being formed here, wow, this is absolutely, I'm rushing not to waste my time. This one is wasting my time. Now, the product formed here, you can see, you can write CH3. So I just don't want to write the dot. I have to calm down. Me ask me to calm down. That's because it is calculation. So let me just calm down. So CH3, you can see CH3. I want to write the product. This is a CBr2, and this is CHBr2. Or you can write CH3, CHBr2, CBr2. So this is the product. So we have to balance, from here it was 2 moles. So I think it's balanced like this. So let's go with what we don't even need the product, but in case question asks you for the products, we know how to 1, 1, 1, 1, 2, 2. That is a tetrabromo. What's this? Propane. So that is that. So, but here now we can now solve the question. How many grams of bromine will be required to completely react with 10 grams of propane? So you can see from here, we compare stoichiometry. You can see 1 mole of propane require how many mole of bromine? 2 moles of bromine. So they now say how many grams of, so 1 mole of a substance is same thing as its molar mass. So 1 mole is molar mass of C3H4 is 3 times, I'm doing molar mass, we've done that today. 3 times 12 is 36. 36 plus 4, 40. So 1 mole of this guy is 40 grams. Require 2 moles of this one is 2 times Br2. Br is 80. So Br2 is 80 times 2, 160. I hope students understand that. Br is 80. Br2 is 2 times 80. Molar mass should not be a problem for you if you want to be a good chemistry student. This is molar mass of Br2. This is 160 gram. So now 2 moles of it, 2 times the molar mass. So 40 gram of propine react with 320 gram of bromine. So they say how many gram of bromine? We now dissolve in 10 gram of propine. We now require X gram, the way your teacher solved in your junior class. So directly you can cross multiply and have your final answer by saying X will now be equals to 320 times 10. These are simple to cut, divided by 40. 0 gets cancelled out. 4 here 1, 4 times 8 is 32, and this is 80. So the amount of gram required is 80 gram of this, and that is the answer. So I hope students understand this and you get what I have done. So let's move to the next one. Now let's use double speed now. Ethane, when passed into concentrated H2SO4, is rapidly absorbed. Yes, ethane, we talked about that. Caustic soda, NaOH, impurities, SO2, and what? CO2. So when you pass what? It's rapidly absorbed. The product of the dilute water, the product is then diluted with water and then warm to produce what I would produce ethanol. So we've talked about that. So I told 18 plus H2SO4 is ethanol. So that is why I'm not going to waste your answer on this. So because it's a line by line stuff. Then the next one is sodium chloride has no solubility product value because of its dash. Now, solubility product, the key concept here is only applicable for insoluble salt, or sparingly soluble salt. So that is when we use what? The solubility product value. I hope students know how to do solubility product value. That's talking about KSP. We're going to talk about it line by line. So keep it in mind. Solubility product is only applicable for insoluble salt or sparingly. So NaCl has no solubility product because it is what? It is very, very soluble. So it has high solubility. So that is the answer to that. The next question we have to move. We have now, which of the following are made by the process of polymerization? So if we go by the polymerization is a constitution of 2 or more monomers. We talk about this also line by line, don't worry. Monomers. Monomers plus monomers. Monomer plus monomer will give you poly. There are numerous examples of polymers. Polymers. I write polynomers because I'm rushing. So sometimes it's like that. So keep it in mind. We have 2 types of polymerization, addition and condensation. I told you I'm going to take line by line. And condensation, don't worry. So for now, let's just take it like this. Now the bigger one we can see here, let's just go with that. Nylon is formed from what? Nylon is a polymer. Nylon is a polymer. From a tin, polythene bag. So soap is not a polymer. You can say this is wrong. Nylon is a polymer. Artificial rubber. Rubber is also a polymer. Rubber is a polymer that is from, there are 2 types, natural and artificial rubber. So you have the monomer for natural rubber is called isoprene 2-methyl butyl 1,3-diene. I will take line by line. Don't worry. Diene is for natural rubber. That's the monomer. That is what is joined together to form that of natural rubber, whereby 2-chlorobutyl 1,3-diene, 2-chlorobutyl 1,3-diene. Sorry, I'm rushing, guys. It's for the artificial or synthetic artificial rubber. So these are the monomer. This is for the monomer of butter. So this is called isoprene. It's important to know, and this guy is called neoprene. So these are just shorty things you can learn here. So this is the answer. I don't need to go for any other thing. So we'll be wrong. So next question is 31 of 35. So we're almost there. Which of the following metal does not form a stable triazocarbonate? Now let's start. The answer to this is aluminium. Yes, aluminium does not form a triazocarbonate at all. And if it's formed, it's going to give you Al2, then CO3, or twice. It is Al3 plus, don't let me write rubbish, then CO3, 2, it is not common in nature. It is why Al2, then CO3. You can see, if I cross multiply, if I say CO3 all twice. So that is why it is not stable. So not stable, in fact, to tell you that aluminum does not form triazocarbon, does not form. So observation, that's what I keep telling you, does not form triazocarbon. So note that it forms, but if it forms, it does not last long. This is a triazocarbonate of aluminium, and that is the answer to that. Question 32. Wow. Question 32 says, a substance Z reacts with NaOH to give a salt and water. For substance to react with another substance to give with a base to give salt and water. Concept of acid, base, and salt. That substance must be what? An acid. Because it is acid that combine with base to give you salt and water. So that is what you just need to keep in mind. So out of answer you want to pick, it must be an acid. When Z is treated with HCl, so after the acid was now added to HCl, you can see my knowledge, it gives a yellow suspension. So yellow, you look for a substance that also have yellow, should be in the trace of that. Into what? Yellow on passing it to what? H2SO4. So okay, a gas evolved would give a yellow when it's passed with H2SO4. So that is when it was now reacted with H2SO4, that was a yellow PP. So now we already know that the substance S is an acid. So out of all these, which one is an acid? This guy is not an acid. This guy is not an acid. So we are left with these two and these two. Now let's take it one by one. So we have sodium hydrogen triazocarbonate is also not an acid. It is an acidic salt. So that is wrong also, acidic salt. So whereas this guy is an acid. So please note that sodium hydride. You can say sodium, you can say hydrosulfide if you don't know how to pronounce it, or you calculate the oxidation state so that you know the OS of this guy. So this is sodium. NaHS is an acid. It is not common. So note that. So the answer to the question will be an acid, like I said. If you don't know how to pronounce, it's not a problem. But if you don't want to know how to pronounce it, get the oxidation state of hydrogen, then pronounce sodium hydrogen or hydrosulfide. So please note that. So sodium 1, or you say sodium tetra, whatever sulfide, or sodium 1 hydrosulfide, anyhow you call it. But that is the answer because this is the salt. So next question is we're almost there. Okay, fine. This question is coming to this direction, and this is question 33 of 35. Ammonia gas is normally dry by. Now, ammonia is NH3, is a base. Because it's a base, we cannot use an acid to dry it because it will react with acid. So this guy is wrong. Quicklime, yes, correct. Quicklime is used. Quicklime is CaO, calcium oxide. This is used to dry. It's a dried ammonia. The same thing, if you react this one, it will react with it. CaCl2 will react with ammonia. The same thing, this is also an acid. Magnesium sulfate cannot anything that will react with the substance cannot be used to dry it. Keep it in mind. So that's the answer to that one. I am rushing. Then the next one, 34, says hydrogen diffuses through a porous plug at the same rate as oxygen, at slower rate as oxygen because of time. So I think this is texting you on the concept of rate of diffusion. Rate of diffusion is inversely proportional to the square root of their molar mass. So I'll take it as density, D2 by D1 directly. So if hydrogen is the first one, RH, over the second one is R naught, this will now be the molecular mass of the second one, which is oxygen. Molecular mass of oxygen, everybody knows, is 32O2, 16 times 2. Hydrogen H2, 1 times 2, 2. So let's just solve this one. RH by R naught is equals to 16, as 32 divided by 2 is 16. I can say 16 over 1, then square root. Square root of 16 is 4. Square root of this guy is 1. So RH over R naught is equals to 4 by 1. So RH equals to 4R naught if you cross multiply, and that gives you an answer to that. So RH is equals to 4R naught, as you can see. So that means its diffuses at 4 times as fast as oxygen. So that is the answer to that from the language interpretation of this. So the last question, maybe I'll leave it for you guys to do as just something for you to do, not that I'll be the one doing it for you. The last question is given that the let's see that again. So we have given that the molecular mass, which is also known as molar mass. I want to expand it for you guys to do it. It's not coming. I hope you can see that now. Now, given that the molecular mass of iron is 56 and that of oxygen is 16, how many moles of iron 3 oxide? How many moles of iron 3 oxide will be contained in 1 kilogram of this? So just convert 1 kilogram to gram, because in mole concept we use mole to be what? Mass to be in gram. So 1000 grams. So just stop this and drop your answer. Please, numbers of moles is equals to mass over molar mass. So it's a simple question. The mass is 1000. The molar mass of iron 3 oxide you use to divide. They already gave you Fe is 56, O is 4. So just write iron 3 oxide out and drop your answer in the comment section. I will be waiting for your response. I hope you enjoyed the first section of our chemistry take that. Like I said, I'm going to be doing a line by line our projected screen, our interactive board chemistry, because I can see that many students they've been writing mails about helping them in chemistry. Chemistry is more of a observation. Observe, know them, write something down. You can't just watch this video without writing that. You have to write something down so that you can always have something to fall back to whenever you have issues. So guys, I'm going to stop here. I hope you enjoyed this section. See you guys soon in the next video. Don't forget to comment, like, and subscribe, and share our channel to friends and people that you think it might be your acquaintance, can be your friend, and it can be your son or daughter. So please try and share them. Let them enjoy this thing. It's a free section and not paying anything for it. So see you guys soon. Bye bye for now. Thank you.